Okay, last problem I want to talk about is a problem like problem 4 on page 420. Things are growing. They're doubling. This is called an exponential growth situation. We'll touch on these more in later sections, but here's the basic idea. Some type of multiplication is happening over and over again. So in this story problem, there's a thousand bacteria in a culture, and they're doubling every hour, each hour. So you start here, multiply by this, and then your exponent is going to be each time it doubles. And this thing changes a lot. Each hour, each minute, each second, each day, each year, each month. You got to pay attention to what each means, okay? So they are just simply asking these two questions. Hey, use this formula and then plug in a 0 for h, and then plug in a -3 for h, and then explain the numbers. Okay, 1,000 times 2 to the 0, and then 1,000 times 2 to the -3. Yep, so I'm going to punch those in my calculator. Actually, this one I don't need to do anything. 2 to the 0 power turns into the 1, A1, and then 1,000 times 1 is just 1,000. Whoa, whoa, whoa. Nothing happened. Exactly. 0. The hours are 0. That means no time has gone by yet. You just started. If the bacteria double every hour and then you just started, there's still going to be 1,000 in there right at that split second that you started. So you don't need to do anything. Now this -3, you're probably confused for a second. Okay, like we're talking about hours. Is that like, I'm confused by that. So I'm going to go ahead and punch it in my calculator, see what she looks like here. Okay, go away. 1,000 times 2 to the power of a -3. Okay, I think, so that's what it looks like in my calculator. You might have to use brackets to make sure that -3 gets in there. I see what you got. Whoa, 125. I thought these bacteria were doubling. Yeah, they are when time is moving forward, okay? So this would be 3 hours ago, okay? Negative numbers in these type of growth models are talking about the past, okay? 3 hours ago, there was probably about 125 bacteria, okay? Because if you had 125 bacteria and they doubled for 3 hours, I wonder what you're going to get. Let's take a look here. 125 times 2, that's another way to write it, to the power of 3. Oh, we're back to 1,000. There we go. So you're kind of going back in time. You're kind of predicting where they were 3 hours ago. Now it's bacteria, and if you have time to count that many bacteria, then power to you, but yeah, not so much, okay? So 0, no time, negative, time ago, and positive is moving into the future, okay? So that's about it. Just plug it in your calculator and get after it. The guided question, I don't even know what the number is. It's 5,400 bugs, I think. That's a lot of bugs. They're tripling every week. So starting number, how it's growing per week. And then again, they want you to do the whole thing. So again, this would be 2 weeks ago. This would be right now. Okay, and then this would be in 1 week. So 2 ago, and then 1 week ahead. Actual prediction of the future. All right, so write them out really nice and slow. See what Mr. Calculator's got to say. You know what? I'm going to write it out nice and slow, and then I'm going to show you how to cheat here really quick. Okay, times are tripling, -2, 0, and then 1. So this one would be easy. Nothing's happening. Okay, and then this one basically just times 3. But I'm going to show you a fast way. Not a fast way, but if you want to have multiple numbers here, oh, go away. What's all this noise? Is that text messages and money? Lame. Okay, watch this. I'm going to type the equation. 5,400 triples every X, where X will be my number of weeks. Okay, let's go to the table. Ooh, yeah, 0 week. Oh, 100 weeks? Oh, look at that. Look at that. The number's so big, the calculator's like, gross, bro. That's a lot of bugs. Okay, 2 weeks ago, there's that many. Right now, in 1 week, boom, instantly calculated. Okay, so if you want, you can calculate each equation, each expression individually, or if you want to go to the calculator, type it in, go to your table. Oop, not the graph. Oh, geez, that's the bugs growing pretty fast. Table, bro. I want to go to the table. Let me go to the table. It's thinking. I don't want to think anymore. Let's go to the table. Ah, here we go. Got it. 2 weeks ago, right now, in 1 week. Ew. So 2 weeks ago, there were 600 bugs. Sounds manageable. And then in 1 week, ew. Okay. So I want to kind of make sure we understand this number, okay, because they may not just straight up give you the numbers. They may say after a month. Okay. Well, if you do a month, that's roughly 4 weeks. Okay. So be careful. Oh, that's disgusting. That's a lot of bugs. So be careful with this number. Okay. This is going to change on you. Okay. Or how you pick this number. Okay. So like they say, every day something happens. And what's going to happen in 2 weeks? That means this number actually would be a 14. Okay, so you got to be careful. Okay? So that's about it. I really got nothing else to show you, friends. Those are basic growth models. We'll be using a lot of those later in Chapter 7, so make sure you're good at those. Again, negatives go backwards in time. 0 is right now, and then positives go into the future and predict future numbers. Okay, goodbye.